Okay, let's get started. I have allergies, so if I sniffle, please don't be grossed out. So we have this equation here, right? We have x to the nth power plus y to the mth power equals x to the all of this. So first what I'm going to do is I'm going to simplify this section right here, and just to try to make it easier to manage once we eventually down here do the powers. So we're going to use this little fact of logarithms to change the base, in that if you have the same base and you have two logarithms and they're being divided by each other, you can change the base. You can have one logarithm where the base is whatever the log is of in the bottom of whatever the log is in the top. So the way I described it is munted, but it's right over here. So here we have a log x and log all of this. So I'm going to change the base to x. Now we have 1 plus x to whatever. And we have this other logarithm here, and we can do the same exact thing, right? We can do log base x of y, and now we get this. So this is where I'm going to do the powers for this x here. We have x to the m times log base x of y. Well, that's just y to the m, right? Because x to the log base x of y is y, and then we have the m left over. And now we have the minus n. Well, the minus n is going to go in the bottom of the fraction, right? Because it's a negative exponent. And so we have 1 plus y to the m divided by x to the nth, log x of all that. And so now this all has been, or sorry, paint is annoying. This all simplified down to this. And so we have x to the nth plus log x of whatever this is. And then we could just do some powers, right? We have x to the nth times um, this is logarithm x, right? So we have times 1 plus y to the nth divided by x n. And we have x to the n, and the x to the n down here cancels, which gives us x to the nth plus y to the m. And I have the whole proof up, so if you if you don't like the way I explained it, you can just read it for yourself. But that's basically how you get it. I have another way of doing it, but if you just wanted to see that it works, that's fine. You can go. I'm not gonna say anything new. But yeah. Okay, so now we're gonna map. I have it written up here. We're gonna map, quote unquote. Really, we're gonna substitute equation one into equation two. And so equation one, I should have had it here, but I don't. It was all of this, except in this corner there was y to the mth divided by x to the nth. And so in equation 2, we proved that y to the m divided by x to the nth is equal to this. So really we just substituted. And now notice this is the easiest thing ever. We have a logarithm and we have all the things on the right side. So we can just use our fact of logarithms to change it into this which is equal to this. And that was the original form of the equation. So that's, I guess, method two, quote unquote, of kind of proving to yourself that this is true. Um, Now I have written down here quadrant demonstrandum, but that's for proofs. This isn't really a proof, and I'll talk about that in a minute. Let me go back to equation one, okay? Okay, so here I'll kind of talk about why this isn't really a proof. So a proof is like, it proves some sort of insanely useful thing that we're going to use all the time. Usually like, think like an equation where you could take some of your known values to find one of the unknowns in a situation where there were previously too many unknowns to solve easily just by setting up one equation. Here, this is just a transformation. This doesn't give you anything useful. We still have all the unknowns that we do in this equation as we do in this equation. Notice that we haven't eliminated any of the variables. There's still an m, there's still multiple n's, there's still x, and there's still, oop, I accidentally rotated it. There's still a y. You see here? So this isn't a proof. I shouldn't have written this down. I shouldn't have written this. It's just a transformation. We're just changing the equation to make it look complicated, which is what Grade did in his original video, and it was actually pretty funny. Now, I I kind of take issue with all the people who are trying who were I did my own research, and I take a lot of issue with people who are trying to be like, oh, I proved it, look, I proved it, because this isn't anything useful. It's just kind of a waste of time. Like, I guess it I don't know, kind of proves that you have a somewhat sophisticated knowledge of logarithms. Because, I mean, I won't lie, I had to look up some properties of logarithms to see, like, oh, what? We can change the base here? Like, I had to do that. Um, so yeah, that's kind of it. I'm sorry if this is like confusing. I did this proof probably like 2 months ago, or maybe 1 month ago, when I found the video by Putin's gay twin in the which I'll put in the description, as well as Grade's original video, with a link to the time that he shows the equation. I just kind of saw it and got down this really big rabbit hole, but it really pissed me off because this is like the simplest thing. Like all you need to know is you need to look up properties of logarithms and then just start changing from the most complicated, which is this section, down to the least complicated, which is this, and then we just get this and this. So, excuse me, that's it. Thanks. Sorry for taking so long. I said I would upload this on Putin's Gay Twins video like a long ass time ago, but I literally forgot. So sorry, but here it is. So yeah, thanks.